Now let's understand the second factor, which is temperature. How solubility of solids in liquids depend on temperature. Now the common example is potassium bromide or potassium chloride, potassium nitrate. For these salts, solubility increases with temperature, right? So let's understand how potassium bromide, when dissolved in water and form a solution, right? Here, this process of dissolution of potassium bromide in water, this is an endothermic process, right? This is your endothermic process. We say the forward reaction is endothermic, right? What we mean by that is, endothermic reactions are those reactions where heat is absorbed, right? So now let's understand why the solubility of these salts increases with increase in temperature. We know, as per Le-Chatelier's principle, right, we say that when temperature is increased, the solubility of potassium bromide will increase in water. So as per Le-Chatelier's principle, when temperature is increased, right, this equilibrium will shift in a direction, right, where heat is absorbed, right? Since we are increasing temperature, as per Le-Chatelier's principle, what change you are doing, it will just nullify that change. Since you are increasing the temperature, right, so as per Le-Chatelier's principle, the increase in temperature would be nullified. When we say increase in temperature is nullified, the reaction will move in a direction where heat is absorbed, right? So we know that heat is absorbed in forward direction, where potassium bromide is dissolving in water to form a solution of potassium bromide in water. So that is why for all endothermic reactions, or for all dissolution process, right, where heat is absorbed, or when the dissolution process is endothermic, the solubility of salt will increase with increase in temperature, right? And it is clear from Le-Chatelier's principle. Similarly, if we talk about salts like sodium carbonate, the solubility of sodium carbonate decreases with increase in temperature, right? Let's understand it here. Sodium carbonate, when added to water to form solution, the solubility of sodium carbonate decreases with high rise in temperature. This is because the reaction is exothermic. Here the reaction was endothermic, here the reaction is exothermic. That is, the forward reaction is exothermic. If forward reaction is exothermic, then the reverse reaction or the backward reaction is endothermic. I'm sorry. When the backward reaction is, by backward reaction we mean where the solubility of sodium carbonate is decreasing, right? Where sodium carbonate is coming out from this solution, that is, its solubility is decreasing. So again, if we apply Le-Chatelier's principle, we know that as per Le-Chatelier's principle, when temperature is increased, so this equilibrium will move in a direction where temperature is decreased, right? So here in forward reaction, temperature is increasing, that is, heat is given out because the reaction is exothermic, so heat is absorbed in the reverse reaction, right? In the reverse reaction. So this equilibrium, on increasing temperature, this equilibrium will shift in the backward direction, where solubility of sodium carbonate is decreasing in solution, right? Where solubility of sodium carbonate is decreasing. So as per Le-Chatelier's principle, when we increase temperature of sodium carbonate solution, the equilibrium, since the dissolution of sodium carbonate in water is an exothermic process, so Le-Chatelier's principle tells us that when temperature is increased, the equilibrium will shift in a direction where heat is absorbed, that is in the backward direction, where solubility of sodium carbonate is decreasing, right? So this is clear. So now we have something known as solubility curves. Solubility curves, right? It's something like this, where temperature is in x-axis and solubility is in y-axis, right? If we take example of potassium bromide or potassium chloride or potassium nitrate, we see that graphs would be like this, right? Maybe this is for potassium bromide, this is for sodium nitrate, this is for potassium nitrate, right? And we say the solubility of these salts increases with increase in temperature. You can see that at this is your temperature, so at higher temperature the solubility is higher, right? At the lower temperature the solubility is lower. You can see for any graph the solubility is lower at lower temperature, right? Now if we talk about sodium carbonate, the graph of sodium carbonate would go like this, or sodium sulfate will go like this, where you see that with increasing temperature the solubility is coming down. Let's take at this point at temperature T1 solubility is this S1, right? And at, let's say, higher temperature, at temperature T2 the solubility is less, S2, right? We know that S2 is less than S1. So solubility for sodium carbonate is decreasing. We can show this graphically. Now these curves are known as continuous curves, continuous solubility curve, because these are continuous, right? There is no breakage in the curve. Now let's talk about a salt, sodium sulfate decahydrate. This salt, solubility of this salt is important. Sodium sulfate decahydrate. If we draw the graph of sodium sulfate decahydrate, the solubility curve of sodium sulfate decahydrate, it would be something like this. Let me just draw it with a different color so that you can see it clearly. It would be like this. It will go first, it will increase, then at this point it will break and it will start decreasing. The solubility of sodium sulfate decahydrate. Now what is the reason for this? We know that solubility increases when the dissolution process is endothermic, right? And solubility decreases, the solubility increases when the dissolution process is endothermic, right? And the solubility decreases, right? It's decreasing when the dissolution process is exothermic, right? So what could have happened till this point? The dissolution of sodium sulfate is similar to this first case, endothermic, right? Where solubility of sodium sulfate is increasing with increase in temperature. Then suddenly at this point it started behaving differently, right? Like that of sodium sulfate or sodium carbonate, right? At this point the dissolution of sodium sulfate is exothermic, and we know that for exothermic reactions solubility decreases with increase in temperature, right? So what could have caused the dissolution process all of a sudden going from endothermic to exothermic, right? What could have happened? It's the transition, right, or change of form of this salt. We know that sodium sulfate decahydrate is a hydrous salt. This is a hydrous salt, right? So at this point this temperature was noticed to be 32.4 degrees Celsius, if I remember it correctly. At 32.4 degrees Celsius there is a break in this curve, right? And solubility at 32.4 degrees Celsius started decreasing for sodium sulfate decahydrate, because sodium sulfate decahydrate changed its form from hydrous to anhydrous at this temperature, right? It's hydrous salt. So at 32.4 degrees Celsius it changed into anhydrous form. right? And the dissolution of hydrous salt, which is this dissolution of hydrous salt is endothermic, right? And dissolution of anhydrous salt, when by becoming anhydrous we mean at this temperature it will lose its water molecules. That is, it will lose its water of crystallization. We call these water molecules as water of crystallization. So at 32.4 degrees Celsius, sodium sulfate decahydrate will lose its water of crystallization and will change into anhydrous form, right? And for anhydrous sodium sulfate, the dissolution process is, the dissolution for anhydrous sodium sulfate is exothermic, right? And we know that for dissolution process that are exothermic, solubility decreases with increase in temperature, and we have understood this from Le Chatelier's earlier. And for endothermic, solubility increases with increase in temperature, right? So this first increased, then decreased because of transition from hydrous form to anhydrous form at 32.4 degrees Celsius, right? So this kind of curve is known as discontinuous curve, right? So due to this salt changing its form from hydrous to anhydrous, we get discontinuous curve, right? And it gets discontinuous at 32.4 degrees Celsius, right? So I hope all this is clear to you. Thanks.